Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When a malonic acid derivative, gem-dicarboxylic acid, i.e. a 1,1-dicarboxylic acid, is heated, it undergoes decarboxylation to give a monocarboxylic acid. The key question is how many stereoisomeric products result from each reaction. Step 1. Identify the substrate structures. Reaction 1, CIS1, 1-bis, carboxyl, cyclopentane with CIS 3,4 dibromo substituents. Decarboxylation at C1 removes one CO2 and generates a new stereocenter at C1 which can form either R or S configuration. Reaction 2, trans same gem-diacid scaffold but with trans 3,4 dibromo substituents. Step 2, decarboxylation of malonic acid derivatives. Heating a gem-dicarboxylic acid, malonic acid type, loses CO2 to give a monocarboxylic acid. The carbon that loses CO2 becomes a new stereocenter. C1 of the ring now bears H, CO2 H, and the ring carbons. So two configurations at C1 are possible in principle. Step 3, Reaction 1, CIS 3,4 dibromo. After decarboxylation, C1 becomes a new stereocenter. The two bromines are CIS to each other at C3 and C4. With the new stereocenter at C1 we can generate two diastereomers. The newly formed C1 center can be R or S relative to the fixed CIS, C3, C4 framework. These two diastereomers are not mirror images of each other, they are diastereomers, so both are distinct compounds. Therefore, X is equal to two products. Step 4, Reaction 2, trans 3,4 dibromo. After decarboxylation, C1 again becomes a new stereocenter. With trans 3,4 dibromo, generating two configurations at C1 gives a pair of enantiomers, because the trans arrangement creates a plane of symmetry relationship between the two possible C1 configurations. These two enantiomers are mirror images and, when considered as a racemic pair from an achiral reaction, are effectively the same compound, or a racemate counted as one compound in terms of constitutional identity. More precisely, the two configurations give an enantiomeric pair, but since they are formed in equal amounts from a symmetric-like process and the trans isomer has a pseudosymmetry, the product is actually a single compound, a racemate. In standard stereochemical analysis, for such cyclopentane systems, the trans substrate upon decarboxylation yields only one distinct compound, accounting for the plane of symmetry making the two configurations equivalent, i.e., a mesolike or single enantiomer situation. Therefore, Y is equal to one product. Step 5, Conclusion. X is equal to 2, Y is equal to 1, which corresponds to option C. Why other options fail? A. 1, 1 ignores the new stereocenter created in reaction 1. B. 1, 2 reverses the counts for X and Y. D. 2, 2 incorrectly assigns two products to reaction 2 when symmetry reduces it to 1. Therefore, the correct answer is C. Therefore, the correct answer is option C.